to move on to our next presentation. Last but not least, certainly not least, we have Gary Chance, who is the Vice President of Marketing and Partnerships for Prescriptive Data. He's responsible for strategic business and hardware partnerships, managing the Prescriptive Data brand, and advancing the world of real estate, sustainability, and artificial intelligence. Gary, you've got the floor. I'll let you take it away.
Awesome. Good afternoon, everyone. So let me just quickly share my screen. 1 second here. Perfect. So today I'm going to start off with a quick presentation about the day in the life of a Nantum chief engineer and our product Nantum OS, and then dive into a demo. So in terms of the way we look at the world of sustainability within commercial real estate, there are 4 major drivers that we mostly focus on. So first, on the enterprise commitments to net zero, specifically around tenants. Your tenants as a real estate operator or your enterprise is making commitments to go carbon zero at some future date. The second segment, as we've discussed a lot during today's different presentations, consumers and investors are both looking for transparency, as well as investors are looking to reward businesses based off their ESG and sustainability impact. The third main driver that we look at is really focused around the different laws being passed across the country. So I know we're all familiar with them, but Boston's Bordeaux 2.0, New York City Local Law 97, BEPS in Washington, D.C., St. Louis, Denver / the state of Colorado, Seattle / the state of Washington, and then about 26 to 28 other markets across the United States that have similar benchmarking laws that are potentially leading up to carbon emission regulation. The deal there is basically laws are being passed that fine owners for their carbon emission usage if they go over a certain set threshold. And that is a big risk segment for real estate owners and operators going forward. And then the last sort of criteria is about energy price volatility and energy risk, which we spend a lot of time researching and focusing on, as energy prices, of course, differ depending on region, city, and so on. So we work with a number of different companies to help them reach carbon zero. And I'm going to talk about how we do that in a second. But our main goal is to help companies put together a plan using technology to reach their carbon zero or carbon negative state across the state of commercial real estate. We look at this as 4 main principles to carbon zero CRE. The first being this leading principle that chief engineers and building operators are at the heart of energy and carbon emission reduction. Our company was originally founded out of Rudin Management. We were born in the engine room of 345 Park Avenue in New York City, and we were designed to solve the challenges of commercial real estate operators through and through. This has been a huge focus for us. It's one of our most proud sort of achievements of having 10 million square feet of an AI and testing lab across Rudin Management's 10 million square feet of Class A office buildings and 5 million square feet of residential buildings. But we work with chief engineers to focus on how they can reduce energy use and hazard sustainability. Our second main sort of principle here is that sustainability in real estate is only possible when it's accompanied by financial ROI within commercial real estate. Again, we come from a real estate institution. We understand the value of asset valuation. We understand the value of NOI and increasing NOI over time. And the best way to implement sustainability and have that sustained momentum around sustainability on a year-over-year basis is bringing it together with financial ROI on a consistent basis. The third sort of quick point here is that sustainability ROI can only be reached with real-time, daily, action-oriented focus. I'll start there. This has to be something that your team focuses on every day, right? The second part to this is opportunities for energy and carbon reduction are perishable. This means that an opportunity yesterday to reduce energy use within your building is lost, right? That's forever gone, that energy reduction that could have happened yesterday. So this has to be focused on a daily basis. And then last but not least, building operators are busy. So real-time daily energy savings are best achieved and sustained year over year through automation. And this is what we focused on for the last 7 years. So let's talk about the day in the life of a Nantum chief engineer. So this would be a chief engineer or building operator using our product every day across their team. So energy savings starts yesterday. Every day starts off with an email for the next day. So for example, understanding tomorrow's weather forecast, recommending preheating or pre-cooling, occupancy analysis, what's the expected occupant arrival time as that changes, and using ML and AI predictive analysis to come to these conclusions. What time should you start your BMS that morning? Whether we recommend a time to building operators or automate, which we'll dive into in a second. But going a step further, what is the probability that you're going to set a new energy peak for your utility costs, right? And then last, what is the probability that you're going to enter our demand response event might happen tomorrow? Some demand response events, of course, you get 24-hour notification, 2-hour notification, 30-minute notification, but what is the probability that an event will happen tomorrow? So this is the look at the traditional building. Most office buildings, large office buildings, teams start up their BMS systems at around 4 a.m., right? And occupants and basically electric demand is the green part of the chart that you see there, and orange is occupancy. Most buildings start their BMS at 4 a.m. when occupants don't arrive until 8 a.m., till 9 a.m., and so on. So there's a big opportunity on a daily basis to reduce energy use every single morning. And what this looks like is if you can use ML and AI to predict occupant arrival time, if you can optimize BMS and HVAC sequencing, you can recommend or automate a startup time closer to actual occupant arrival time. And this means energy savings every single morning on a consistent basis. Again, this idea of how do you use something every single day to meet your carbon reduction goals. Right, and then throughout the day, as you see the previous start time versus the new start time. And then beyond that, middle of the day, using real-time occupancy and measuring real-time comfort to adjust BMS set points, fan speeds, Wi-Fi thermostats, whatever the equipment may be, we're completely agnostic and considered middleware. We're able to use the least amount of energy humanly possible to provide the maximum amount of comfort, all automated in real time. So what you see here, and we'll dive into later in the actual demo, again, throughout the day at lunchtime as people leave, we are reducing that green part of the chart, the electric demand in terms of kilowatts, based off of real-time occupancy. And as people return, we ramp back up the building, always guaranteeing comfort. And towards the end of the day, analyzing as people leave the building in certain key thresholds, and also predicting people leaving, and also measuring the building's innate thermal inertia, we're able to shut down BMS systems, again, saving energy throughout the day. So again, daily energy savings, consistent and persistent. So let's talk about real-time energy management. So the idea here is to allow operators to gamify daily real-time energy management. So what you'll see in the chart on the right, sort of labeled as predictive curve, that gray dotted line, this is Nantum predicting based on a weather normalized similar day, what electric demand will look like that day. The dotted vertical line you'll see is the BMS start time, otherwise known as the game sort of starting. What time did we start up our BMS, which is visualized across every chart within Nantum. And then the real-time electric demand, that blue line. So this allows operators and chief engineers to visualize in real time, how are they performing on a daily basis. And as you'll see in the demo, this is usually put up on a large screen in terms of real-time energy management, but allows operators to see how are they comparing to a similar day in a previous historic. So being able to compare yourself and how are you operating your building better. And then last but not least, that red line being your peak demand benchmark. This is where if your electric demand goes over that red line, you have set a new peak benchmark and are basically incurring new peak demand charges on your energy bill. So again, focusing on this ROI, the financial side, being able to alert operators before they hit a new peak demand benchmark, and then using what we call ADM or automated demand management, giving operators literally with the click of the button and sequencing the ability to avoid setting a new peak, saving thousands of dollars, and sharing with them that information of energy cost savings. So peak demand charges represent usually 30 to 70% of utility bills. Being able to make a dent in your peak demand charges will pay for a lot of other instrumentation within the building, capital upgrades, and other things that we'll talk about in a second. So this is the visualization, and we'll see it in real time, but this is literally the building avoiding setting a new peak and saving thousands of dollars while maximizing tenant comfort, and that's a key part we'll talk about. So similar technology we use for demand response programs. So if you're not familiar with demand response, the 30-second overview would be during the summer when everyone has their ACs cranking because it's over 100 degrees. And we've already talked a little bit about climate and weather risk earlier today. Utility companies may run out of electric demand. They may not be able to support all the electricity needed across a region. So it's more economical for a utility provider to pay an owner to reduce their energy use in a time of need than it would be to spin up, for example, a dirty coal plant. So this program, demand response, has been around 20 years, I believe, maybe a little bit longer. The idea here is to help automate those different programs. So in the typical demand response program, it's sort of a pain for building operators to run around the building, shutting down lights, elevators, other building equipment. We automate those sequences for building operators so they can not only be more efficient in their process and spend more time on day-to-day tasks, but also collect more demand response revenue. Again, getting back to this idea that sustainability needs to be tied with ROI. And then last but not least, in terms of the story, working with partners to procure renewable energy and RECs. So as you create new revenue through energy reduction and cost savings, through peak demand savings, and through demand response incentive programs participation, this gives you a really good financial benchmark to start your process of procuring and purchasing renewable energy and renewable energy RECs, or credits rather. So the idea, we work with partners to allow our customers to visualize not only their energy consumed, but also their procured renewable energy, their renewable energy RECs, and that delta between the two demonstrated in that net energy in the blue line and in the bottom chart to the right. What is their net delta? And this is super helpful in situations like Local Law 97, where this is what owners will be fined off of. So last but not least, just in terms of tracking and predictive analytics. So again, I'll show this to you in the live demo, but being able to visualize real-time carbon emissions and also predict carbon emissions. So in this case, what you're seeing is the green line represented up here is the actual carbon emission consumption. The gray line specifically is the predicted carbon emissions. So this gives operators, and we'll see in the demo, a real live view of what Nantum predicts their carbon emission count will be versus how they actually performed on a month-to-month, day-to-day, year-over-year basis. And then finally, automated reporting, right? Being able to easily export, view, and make your GREBs and ESG reporting a little bit easier. And then finally, celebrating daily wins, being able to, on a daily basis, weekly basis, monthly, quarterly, whatever cadence you're looking for, being able to share with the chief engineers and the operations team, what is their energy and dollar savings? How much money did they avoid spending in terms of peak demand avoidance? What was their return to work look like in terms of occupancy percentage? What was their carbon emission reduction? What was their water reduction? At the end of the day, coming up with the KPIs and working with each of our customers to better understand their metrics and report back to them their success on whatever cadence they're looking for. And daily wins leads to annual building performance, right? If you can save energy every weekday and going into the weekends as well, that leads to annual performance across a building. And annual performance across a building leads to portfolio performance overall. So with that being said, what I'd like to do is jump to a demo. So this is Nantum OS. What you're looking at is real-time data from Rudin Management's portfolio. So again, we are a middleware. So what you'll see here, and this is a custom dashboard created by each chief engineer, and this is what the operations team at Rudin Management chooses to see. But they'll see real-time temperature, and this could be coming from a BMS system, IAQ sensors, indoor air quality sensors, different vendors. We normalize all data and put it into a single building operating system ecosystem to be compared and contrast. So real-time occupancy right now at 345 Park Avenue, real-time steam, electricity, so on and so forth. And then going into aggregate data, how many people are in the Rudin portfolio right now in real time? What does their electric demand look like? Their electric consumption, their water consumption, so on and so forth, and then report against the entire portfolio, against any date range of historical data that's stored within Nantum. So taking that a step further, and diving in specifically to 345 Park Avenue. This is the building that we were born in. And what you see here, 1 second here. This is real-time data coming from what we call the building cockpit. This is the view at 345 Park Avenue that's customizable, that the chief engineer will have on a big TV within their office within the building. And as we go through these segments, and I'm going to go in sort of backwards order here, but it will make sense in a second. We see real-time steam demand for the building, real-time occupancy within the building, real-time interior space temperature. So each one of these different lines represents a different either temperature sensor or zone and can be completely customized. What you'll also see here is these gray boxes. So as the BMS starts up, as an example, this is the time BMS started up this morning, you'll see temperatures start to reach their SLA requirements. This light gray box here is the best SLA requirement zone. So quickly visualize which of your sensors are meeting the SLA requirements. These lighter gray zones are still meet the requirements, but it's a quick way for an operator to visualize, for example, a specific sensor in a specific zone that might be misbehaving in some sort of way to go identify what's happening. But the general idea is to understand what's happening in terms of building performance in real time. Again, going back to this building cockpit, what you'll also see up here is new building activities. So Nantum has two types of anomaly detections. One is user created, being able to set a certain threshold for any type of data that's in Nantum, whether it goes above or below it, being able to be alerted and setting different thresholds specifically for severity of that alert, but also AI-driven alerts, which we group together, which I will show you in 1 second as well. In terms of the building itself, real-time occupancy, schedule. So this is where our automation comes in that we talked about a little bit. What you can see is that the average building within Nantum ramps up in the morning on the electric demand curve, drops down as people leave for lunch, turns back up as people return from lunch, and then sort of coast off towards the end of the day as an expected participation. This is what you're seeing for Nantum in terms of recommending or automating these different scheduled steps. So we recommended this morning, the building we started up at 6:33 a.m., ramp down for lunch, 11:13, a little earlier because the building's only about 50% occupied, ramp back up at around 12:30, and then final ramp down unscheduled, which will most likely happen as people leave the building earlier just because of occupancy levels. But the general idea here is a quick view of what's going to happen across the BMS's automation for that day, and then diving in specifically to what we talked about earlier, the real-time energy management. So being able with a quick look to understand where do we expect the building to perform in terms of kilowatts today, the benchmark, where is it currently? In terms of the today, Thursday, this 5-day forecast, which of these days do we expect the building to potentially hit peak demand and incur new peak demand charges? So today was a definite day. Thursday and Friday are most likely, or of course, Saturday and Sunday are weekend days. So we're not worried about those, or Nantum's not. And then visualizing today in real time. And what you can see here, again, is that demand curve, the BMS startup time, and then the real-time electric demand. And what you can see in action here is our automated demand management. So being able to avert this building from setting a new peak today based on actual occupancy and making that decision as a team with the chief engineer. So I know we're running up on time, 10 minutes left. I just want to show a few more things and then answer any questions anyone has. So to kind of give a quick overlook in terms of Nantum's anomaly detection, being able to group different types of anomalies together so that your operations team isn't responding to 1,000 different alerts at the same time, grouping them based off of what they happen at the same time. Does this mean a bigger incident? Which of these alerts are most important and most critical and most crucial? Because that's a big problem with fault detection, FD&D, fault detection and diagnosis software. The other type is data types. Nantum can ingest any operational data into the building. In this case, there are cooling towers. So we put IoT pH sensors within the cooling towers to detect whether or not there's Legionnaire disease, just because New York City has different laws about the pH levels within cooling towers. Real-time electrical consumption, electrical demand. All HVAC data, both historical and then real-time, and customized into your own custom KPIs. We talked about occupancy. We have power quality being able to be visualized, interior temperature, weather, any data type within Nantum can be visualized. And then beyond that, sensor management, if you can tell in this building, there are almost 2,000 active sensors across this building. So being able to quickly find, manage, and even categorize. These sensors were installed before we'd actually launched the category section of Nantum. So these sensors have been in place since, I believe, around about 8 years now. And then finally, most importantly, as we talk about sustainability, the app section. So real-time carbon emission management. So what you'll quickly see here, as I pull out the legend, you'll see this red line, which represents local law 97 2024 benchmark for this building, identified by Nantum as how this building should behave based off that law. So basically, this is a guiding line for building operators in terms of what carbon emissions should be doing in this day, and so giving them something to beat. You'll see the same thing in terms of aggregate. Where is this building performing versus local law 97's 2024 fine limit, and then 2030. So being able to quickly visualize this building has a little bit more work to do before 2030 comes, being fined in local law 97. Visualizing that same data on a month-to-month basis. So being able to see real-time actual carbon emissions from this building, calculated from all the different types of meter data. Again, the 2024 benchmark, the 2030 benchmark, and Nantum's prediction of behavior, and again, across the aggregate. And then last but not least, the ability to analyze this data in terms of cost savings across any dimension or any time frame. And I'm happy to answer more questions because we are running up on time, but a fun game we like to play if you come visit us at our office in New York. This is a special day, August 21st, 2017. We usually play a game where people get to guess what happened on this day. As you can see, it looked like a normal day, but occupancy sort of dipped here drastically and came back. I'll just kind of give you the secret. This day was the solar eclipse, where everyone at this building basically went outside to view the solar eclipse. And what you can see, and why this day is important to us, is this is the first time we saw Nantum sort of act on its own. It realized that people were leaving the building, and there was an unexpected pattern because it expected the building to act this way. And it reduced electric demand in real time based off of that, or what it thought was real time based off of occupancy drop. And then as people returned and surprised it, it started to catch up with people and then drop down towards the end of the day. But this just gives you an example of what it means to automate your BMS system. And then last but not least, I think it'd be important to just leave you with sort of our case studies. So in Rudin, as measured specifically by NYSERDA, we save Rudin management about $5.5 million every single year consistently based off their baseline year. And Rudin is only using about 7 or 8 occupancy sensors in the lobbies of each of their buildings to detect whole building occupancy ins and outs, connecting Nantum to their meters, and then connecting Nantum to their BMS on a whole building basis. This energy savings, of course, scales as you can automate as floor by floor or zone by zone basis. But my point in telling you this story is that it's quite simple to get involved or start working on automation tomorrow. You only need 3 major data points: connectivity to your meters and submeters to measure success, connectivity to your BMS system or HVAC systems or even Wi-Fi thermostats, and then last but not least, whole building occupancy, which every day gets more affordable to achieve on an everyday basis. So that's, I think, all we have time for. I think I'll stop there and answer any questions, but I hope that was helpful and allowed people to see what we've been working on, what we've been focusing on.
Thanks, Gary. Oh, that was amazing. Speaking of case studies, so to say, can you share some of the recent work that you guys done using Nantum OS with JP Morgan?
Sure. So about, I think it was 3 weeks ago, we officially announced that Nantum OS will be rolling out across JP Morgan Chase's global real estate portfolio. We have a very long white paper coming out specifically about that in collaboration with a few partners, including KPMG and the World Green Building Council, which I'll be happy to share. But it's a project that we first started working with JPMC, I believe it was about 3 years ago, in a few of their buildings in New York City. And what we've done is design a 10-step program, which is available on our website, the 10 steps to getting to carbon zero. And it's very similar to what I presented earlier today, but it starts off with measuring and understanding where you are. The second step is automating your actual carbon emission reduction. The third step is bringing in and procuring renewable energies or interacting with distributed energy resources. And then that fourth step being verify. How do you work with a firm to verify your carbon emission reduction and that you have in fact gone carbon zero and carbon negative? So happy to share that. It's also definitely available publicly on our website as well.
Awesome. Thanks for that. Got a couple of other questions here. From Matt Lynch, how do you determine the sequencing for each building that operates, the operators can enact in a DR event?
Absolutely. So the first step is taking historical data and comparing it to what happened during a DR event and better understanding what those energy savings look like during a DR event. The second step is working directly with those building operators and chief engineers and putting together a list of what their usual performance looks like during a DR event. And then from that, understanding where should we start optimizing or sequencing. So figuring out, working with that team, where do we start? What is your usual sequence? And then replicating that sequence as a test within the actual building, getting that chief engineer team comfortable with automation. That's a big part of what we spend a lot of time on. There's a sort of growth path to when you say the word artificial intelligence and talk to a building's operation team. It starts off with just understanding what their usual processes are. Then it usually leads to showing them the value of AI and ML driven alerting capabilities. Fourth sort of step is what we recommend, such as a DR event, and then building that trust towards automation. It's definitely sort of a scale and takes a lot of handholding, which is why we have an amazing customer success team, which spends a ton of time with chief operators and individual building managers.
Great. Another question here. How do you obtain occupancy data in buildings that don't have the sensor capability natively?
Absolutely. So we try to work with whatever is existing in the building. And I'll give an example of that. In New York City, there are a lot of lobby turnstiles, which we'll try to use data from. The problem with those is they usually don't count outs. They're really good at counting how many people went into the building, but they have no idea how many people left the building. Our second strategy, depending on how the building's built, is if you can use Wi-Fi device scraping to count people within the building. And after that analysis, and all this analysis is free, we have a massive partner network in terms of finding the most cost-efficient way to count people in buildings. And again, it only starts with your lobby, and you have whole building metrics. Once you have those cost savings, you can start deploying it on floor by floor, such as elevator banks or outside key doorways in terms of stairwells. But it's part of our onboarding process and proposal process. We find the most economical way to count people in your building for you and allow you to take advantage of that through energy savings.
Awesome. Thanks, Gary. How can folks get in touch with you? They'd like to learn more or have any other questions?
Absolutely. So our website, I believe, is up here, prescriptivedata.io. But to get in touch with me directly, my name is Gary Chance. My email is gchance@prescriptivedata.io. Or feel free to request a demo. I see every single one that comes through on our website, but happy to spend the time to tell you more, to show you more, and let you learn a little bit more about how we combine sustainability and ROI and how that needs to be the future of real estate sustainability.
Awesome. Well, thanks a lot, Gary. That brings us right to the end of the demo day. Appreciate the demo here. Thank you, everyone, for joining.